Before we talk about the actual translation process, I want to do a little bit of an introductory activity. And so this one is called the DNA Introduction Decoding Activity. You see it in this week's folder. So if you want to take that sheet, and again, pause the video if I get ahead of you, take this sheet and push it out into OneNote, please. And we'll take a look at that just to get an idea of what's happening with the idea of translation and what's going on in our bodies. Okay, so here's the sheet that we had in OneNote, and it said, why did scientists decode the entire length of DNA? So our DNA is messages, it's instructions on the body. And so when you look at what's below, you remember that our DNA, you guys, it's a series of A's, T's, C's, and G's. It's a code, it's coded. And, like any code, you got to figure out the code to understand what's going on. And so scientists, it started in the late 90s and went into the early 2000s trying to decode the human genome. And so they were literally working with 4 letters of the alphabet, A, T, C, and G, and they were trying to figure out, what does it all mean? Well, to give you an idea of the confusion of that, here's one paragraph, and there's extra letters in there, and there's words you'll recognize, but there's no punctuation, there's no capitalization, it's just running on letters. And your job is to go through this and try to find the actual message that's contained inside, however you want to do it. Highlight or underline. And so I'll get you started, and you have to go really slow starting out, because again, there's lots of extra letters that you don't need. Decoding the human genome sequence can, and keep going. Go through just this paragraph and try to find the actual message. I'll have you pause the video and we'll take a look at what the completed message looks like. But please go ahead, pause the video and get your highlighter out and see if you can find the message inside this jumble of letters without any kind of punctuation or capitalization. All right, here it is. Here is the actual message. If we get rid of all the letters that aren't needed, decoding the human genome sequence can be compared to reading a book that was printed incorrectly. Imagine the long book written without capitalization or punctuation, without breaks between words, sentences, or paragraphs, and with strings of letters scattered between and within sentences. In order to understand what is written, the jumbled text has to be decoded. Think about that, those of you that like to read. Imagine reading a book that you've never read before, and there's no capitalization, there's no periods, there's no commas, and there's extra letters that you don't need, and you have to try to read the book. I enjoy reading. I couldn't imagine that. I don't know that I would read if that was the case. But there's one other thing that some of you may be picked up on that I want to show you, and I'm going to go, I've got one more copy of this. How many of you noticed what I've got highlighted in pink? That in front of anything meaningful, there's some DNA TATA. It's called the promoter region. And what scientists have learned is that every protein in every single organism starts with a promoter region, and that promoter region is a series of T's and A's. Now this one has it just TATA. Sometimes it's more than that. Sometimes it's multiple T's and multiple A's. But scientists really don't understand that yet. Why? But it's called the promoter region, and this TATA sequence, promoter region, is kind of telling the body that, hey, the protein hasn't started, but it's about to. It's kind of like when you go to the movies, when people actually used to do that. You'd sit in the theater, and when the lights go dark, oh, the movie's about to start. The movie hasn't started yet because you got to do the previews, but once the lights go down, it's kind of that indicator like, oh, it's about to begin. That's what that TATA region, it's called the promoter region. It's not a part of the protein, but it's just saying, hey, protein's about to begin. So this kind of leads into what we're about to talk about with translation. So I just wanted you to see this part of it